Hello, I am Moodida, and welcome back to Satisfactory. If you are new here, welcome! I was looking for a challenge for a new playthrough, and I decided to load balance just about everything. So there are 0 factories with manifolds in this world. This is episode 35 of the load balance playthrough, and today I'm going to tackle the third Phase 4 space elevator part, thermal propulsion rockets. I have all the alternate recipes. I'm going to utilize the solid steel ingots, all-clad casing, iron wire, cast screws, steel rotor, heat exchanger, cooling device, and turbo pressure motor alt recipes. These are fantastic alternates to the default recipes that save on raw resources and, most importantly, give me nice even numbers to work with. I already have the Fused Modular Frames, pressure conversion cubes, aluminum ingots, and rubber that I'll need for this, and I'll be using drones to bring all that in. I'm going to be using this spot and these nodes here. Okay, so I know this flowchart looks a little bit crazy, but let me break it down and I promise it's really not too bad. So first thing you'll notice is that there's those 4 gold boxes that are slightly different colored than the orange. Those are all the ones that I already have completed and I'm bringing in, and I'll be using drones for all of that. So the fact that I already have 5 pressure conversion cubes and 10 fused modular frames cuts out just a huge amount of machines and hassle. So let's start down here at the bottom. So for the iron and the coal, it's fairly simple. I just need a whole bunch of ingots for everything because I'll be using the solid steel ingot. So I need at least 27 foundries, probably be doing 28. And then all of the steel ingots are getting turned into steel pipes. And then the steel pipes are needed for the stators and the rotors. The rest of the iron is getting split between iron wire, cast screws, and iron plates. The screws and plates get turned into reinforced iron plates, and I need a few rotors to combine those and make my smart plating. So if you look at the next section, we're basically going to be taking those stators and those rotors, turning them into motors. The motors need to get split in a couple different places. I need to send them to modular engines, turbo pressure motors. That's a little bit cut off, but it's going to the cooling devices. This is the top part of the graph. So with the aluminum ingots, I need to empty fluid tanks, combine that with some nitrogen gas, and then that's most of what I need for cooling devices. I just need some heat sinks, so I'll be using the heat exchanger. I just need aluminum casings and some of the rubber that I'll be bringing in by drones. And all of this craziness will net me 10 thermal propulsion rockets per minute. And here we are in what I think is called the Western Dune Forest, just north of the grassy fields. So as you can see if we zoom in, I've got a couple of the foundations set, so I'm going to put some towers right there, and that's going to take care of the wire using that iron wire recipe. I also need a little bit of copper, so I'm going to be using that node right there. And then the rest of the iron is going to be coming from the pure nodes that are right down over here. And we've got the main aluminum plant right there, and some extra coal nodes that I'm not using in the red jungle that I'll be able to just bust down into the factory. So I'm going to be able to get the wire, the copper ingots, iron ingots, and reinforced iron plates all done, but most of the manufacturing is going to be done right here in the middle. I'm going to create a decent sized factory, and then we've got our nitrogen node right here. So let me create some towers and I'll show you what it looks like. And voila, we have some towers. So with the iron wire, it's not the most efficient as far as number of machines that you need. Thankfully they're only constructors and those don't use a ton of power. So I need a minimum of 134 machines. So one section will be slightly underclocked, but it works out really nicely with the towers because these are actually all impure nodes that I'm using. So the most I can get is 300 out of each one. But with each machine using 12.5, I get a nice even 24 machines, which is a great number to work with for the load balancing. So each impure node will output 540 wire. And then we'll just have to underclock the very last one. And I've also got the tower set for over here. So I just need 2 short ones to do all of the iron ingots, and that'll be used for the solid steel recipe. And then the bigger tower will make all of the reinforced iron plates. And then we've got the base of the tower. So this is going to have to be quite a bit taller because not all of the machines are going to fit on here. But this was about as big as I could get it without it having to be much taller so that I could just go over everything. So I still wanted it to be a little bit more in line with the nature, but not having to take up too more. So I'm gonna have to come up with some sort of support under here because for right now it's floating. But that shouldn't be too hard. Unfortunately, this save file is getting a bit big, and I can't tell you the amount of times that the game crashed building this factory, so I'm not going to recreate too much of the actual building, and this is going to be more of a tour of this factory. So let me skip ahead again, so we have some machines in place, and I'll go through it. And we're back. So I know my storage unit is right there, but I'm lazy, and I really didn't want to have to go and get things every time I needed stuff, so I did just still put down my mobile storage unit with drone port to get all my goods. It's still faster. Once you get used to it, you just can't go back. So let's take a quick tour, and then I can tell you my horrible mistake. So load balancing the iron wire, really simple. If we come down here to the bottom, we've got the miner. This is the one tower that is underclocked. And then we've just got the 5 smelter blueprints. And then those will feed into a bunch of 4 constructor blueprints all the way up. And these ones are underclocked. This tower, which has a couple nodes, I decided to do it actually vertically. So even though it's 3 sets of smelters on each floor, and I could then redistribute it, it works out really conveniently that each group of 5 smelters will feed 2 floors of just 4 constructors. So I'm going to end up doing this vertically in 3 groups, essentially, instead of combining things and then resplit them up. But I'll show that off later. Really simple little copper setup. I only need 5 smelters because I need exactly 150 copper ingots. And over here on the coast, which apparently is called Long Beach. I was looking at the map that lists out the more detailed biomes, and I had no idea that this little section was called Long Beach. So the iron setup's really simple, don't really need to spend too much time on it. Just a bunch of iron smelters all stacked up on each other. And then in the reinforced iron plates, since we're just using the default recipe, I've used this dozens of times it feels like already. So the main tower got a little bit taller, got a few machines in place. So let me go through it briefly. Foundries are going to be right here, and there's a reason why they're missing. But I'll go over that in a second. Steel pipes, all the constructors are going here. Because I have that empty space, I'm going to do a little bit of the load balancing and logistics for this floor underneath, just because I can. The rest of the floors are going to get a little bit more busy. So on this floor, we are going to make rotors with some of the steel pipes and the wire. We're also going to make stators using the rest of the steel pipes and the wire. Now this right here is my big mistake. I was so good with my spreadsheets in the early game, but I think I planned out a little too far ahead, and I didn't finish this section, and there were a couple things I missed, and one of them was a cell for stators. Because I do need 170 stators for all of the motors, which is that back section right there. But I also need 40 stators for the turbo pressure motors. So pretty much everything for this section and below needs to get redone. Everything above it was fine, because it was under the assumption that I was actually going to do that part right. So I need to tear up the steel pipes. I already tore up the foundry, so I need to add a few more. I also unfortunately need to add more wire, but thankfully that's really easy because I actually have some extra nodes that I wasn't using because I was supposed to use them. I knew I was supposed to at some point. So gonna have to redo that. Gonna have to figure out how to squeeze in more assemblers because I really want to keep them in this space. So this is gonna get real interesting. But before we jump to that, let me go through the rest of it real quick. So like I mentioned, motors are here in the back corner. So I need 85 motors and just a nice little setup for those. The one bit of load balancing that I did on here is because I need so much wire. So I needed 44 assemblers for all of the rotors, but that's not really a great number to work with for load balancing. You can definitely load balance 11, just split it 12 ways and cycle back. one of them into a merger into the beginning. But I didn't want to do that. So instead I went with 5 groups of 9 to give me 45, and then they're ever so slightly underclocked. Because all the steel pipes fit on one belt, load balancing this really pretty easy. Just do a 5-way split for the 5 rows, and then a normal 9-way split from there. The wire needs at least 2 belts, and the easiest way I could come up with was this. So what I'm doing is I'm splitting 2 belts that are going to come in equally. Each one of them are going to go into a splitter, and then we're going to do that modified 5-way split where it's the splitter first instead of the merger, and then it goes into a merger. This merger goes into our 3/5, so 1, 2, and 3. This merger goes into the splitter that has 2/5, so there's 1/5, 2/5, and then that third piece is the one that gets cycled back. But because there's so much coming in on that belt, we can't do the normal 5-way. So instead we put it into a splitter, we split that, and send it into each of those mergers. So it functions the same as the normal 5-way split that I've used so many times, but now I don't have any throughput issues. But since I'm bringing in 2 belts and I have 5 rows, what I need to do is split each one. Each row is going to get 2/5 of each of those belts. So that's why it's set up so on this side 2/5 are in a merger heading off. That last one is getting merged up with one of the 5ths on this side. And that last 5th is headed over to the middle. And then we just have a mirror set up on that side, sending that leftover one to this middle. And that's how I did the load balancing for all of the rotors. So now we have this floor, but because it's also the final floor, I'm going to skip it for a second. Because on this floor, I needed 25 manufacturers, and that was going to take up a pretty good size of space, so I decided to just give this its own floor. So since all 3 of the inputs come in on 1 belt each, I was able to keep things fairly simple, and we just have a normal 5-way split where it goes the merger first into the splitter. Each one splits off all 3 ways. This one feeds 3/5, this one feeds 2/5, and the rest of it cycles back into that merger. And then for each row, that just happens again, and that's how we have our 25. So this floor is dedicated to the modular engines, and this one right here is our final floor. So we're making the heat sinks and the cooling devices pretty much right next to each other. So since I needed 8 blenders and I needed at least 7.5 assemblers, I figured this was going to be a really nice and easy way to set it up, so I could just feed in the assemblers and then the assemblers can just feed straight into the blenders. At the back end of this floor, I've got 25 assemblers making the 50 smart plating. So really simple, just like the floor above. It's just 5 assemblers in a row, and then there's 5 rows. So just doing a 5-way split into another 5-way split. Tucked here in the corner, I've got 3 manufacturers, and these are kind of facing the other way because these are making the 10 turbo motors, which are getting fed directly into the 10 manufacturers making the thermal propulsion rockets. So this is where I realized that I was missing 40 stators, because I remembered thinking I was only making enough stators for all of the motors since I had just belted that up. And this is where I needed to spend an hour or 2 redoing a whole bunch of things. But let me jump ahead to the next horrible realization that I had. And we're back. So I added a few more bits to the towers, basically 2 more towers to add up for all of the missing wire that I needed. The reinforced iron plates were totally fine. I just needed to make the iron smelting towers just a little bit bigger to make up for the extra iron ingots I would need for the extra steel that I was missing. So I got the drones running. This one is bringing in the rubber. This one's bringing in batteries. Oh my. I didn't realize it could take me out like that. So this one's bringing in the batteries. And the last one is bringing in the fused modular frames and pressure conversion cubes from the Rocky Desert. And this one is going to take the really short trip over to the space elevator. Obviously I could make a belt, but I already built those drone ports, so I might as well use them. So after getting this set up, I figured, well, let's take a look at the power. And oh no, not again. Yeah, and in the last episode I said I sure hope adding another train didn't cause me more issues. Yeah, well, it did. And the solution is Adding more trains. Basically, the problem is almost all of the trains were a little too tight on their timing. So when there was very little traffic, they were all fine. And there was just enough leeway where if they hit one spot with a little bit of traffic and had to wait for, 30 seconds or something, it would be fine. Adding so many trains when I did my nuclear power plant, it just kind of wrecked everything. And so the solution is actually to have almost everything have 2 trains running on its route. So that's what I'm going to have to do, and it will sort itself out, but it is just kind of a pain. Well, time to build some trains. So I'm done playing conductor for now. Hopefully that'll fix everything. It does take a while. Thankfully, with the load balancing, things catch up pretty quickly. But with the cycle time being so long on so many of those recipes, it will take a while to sort itself out. But I squeezed in all of the foundries that I needed on this floor, and that really wasn't too bad. They just had to come all the way to the edge, but not too horrible. Now, with the assemblers over here, things got a little bit tighter. So for this, I needed to come up with a new, even more compact blueprint. So I came up with these 2 assemblers for left and right, and yeah, the load balancing for this was interesting. So I need 3 belts of wires. Each one is going to have 560 on it. Each row has 14 assemblers in there. So I have exactly the amount of assemblers that I needed, but it's a pretty tight squeeze getting it all to fit in here, and it was pretty much as close as I can get it. But hey, made it work. This is just doing a really interesting split. So since I needed 14 in each of these rows, that meant I was going to need to do basically like a 7-way and a 7-way split. So that meant splitting it 8 ways in total. Hence the line right here that's getting cycled back to the very beginning where there's 2 mergers. And I just did that on both sides. So split it 8 ways, and then I have 1/8 from either side coming back, giving me the 14-way split that I need. And the amounts are low enough that it works. And since I'm using the frame foundations for pillar supports, they're nice and hollow, so I can use them to run all my lifts up and down. So that's how I'm getting things from floor to floor. Now let's take a look inside the basement. Alright, so we've got some sinks and actually a few machines. So let me go through those real quick. So since I needed so few to make the packaged nitrogen and the aluminum casings, I decided just to hide them down here instead of taking up a whole section up there. So packaged nitrogen, super simple. The constructors make the 60 empty fluid tanks, so everything is pretty smooth, nice and simple. For all of this, I wanted to get all of the towers up and running, and I wanted to be able to do the same thing I did with the last factory, where I just have a priority power switch. Everything will be on, and then I've got smart splitters set up, so as soon as I turn off all of the sinks, then the products will all flow into the factory at once. This will just make things a lot easier, especially because some things will come in a lot faster, like the iron ingots are being made at a way higher rate than the reinforced iron plates, where I'm only making 50. If I were to turn everything on all at once, the reinforced iron plates would take just absolutely forever to get here. Everything else would be backed up, and then I'd have to clear out all those lines later. So this is a much easier solution. Get everything into the factory, and then we can watch it all spring to life. So I've done some of the load balancing already to send things off. Like these, for example, are the 2 coal lines that are coming in, and I'm just sending them into a 2 to 3 load balancer. So then I just have 3 equal lines going to the 3 different sections of foundries. And that's doing the same thing for the iron ingots that are coming in on 2 belts. And since it's all just iron ingots and wire, I'm just going to go ahead and skip that, and let's go ahead and jump to the next part. Alright, we're back. Drones are dropping off their stuff, and each one is real simple, just using the blueprint that I made last time. So this is separating the fused modular frames and pressure conversion cubes, just using a smart splitter to split those, and then they're being load balanced. These ones are real simple since I only need 10 of these and 5 of these. Just a 60 belt, split it 3 ways, 20, 20, 20. Split one of them in half, and I've got 10 and 10. And then for the 5, it's the same thing, just put one more splitter. So we take that 10 and then split that in half, so we've only got 5. And then those are all coming down here into this nice little platform that's holding it all up, and also logistics for all of this stuff. So we've got the rubber coming in here. This is going to be the export line. Got my lines of nitrogen. We've got the iron ingots and the reinforced iron plates, and obviously the cubes. I decided to switch it up and try to make the power as minimal as possible, so I just added a beam in kind of a low profile spot to not be too high up, and then just used that to run the wire. And that way I could use fewer connections and use some of the Mark IIs and 3s for some of this, for whichever one is convenient. And if we head down here, we've got everything running, and everything got a little bit busier with all the rest of the products coming in here. I was running a sink next to the drone ports, but I didn't want to have to switch everything over, so I decided to just run that down here. So on this side, it's most of the iron products and the things that are coming in from the drones. And on this side, we have lots and lots of wire, which just blur. So for the rest of the factory, it's pretty straightforward. I'm just using these pillars to run most of the products up from floor to floor. So over here, we've got a bunch of it and the pipes. So this is one of the busier ones. Bringing it up to the right floor. And on this floor, I decided to add a sink because the rubber is going to come in at such a high rate. It's going to fill all of these machines well before these ever receive motors or smart platings. So this will just keep it from backing all the way up to the drone port. And once these get started, I'll be able to clear out the line really easily and then just delete it. The only bit of load balancing that I really had to do from one floor to the next was this right here. So with the motors, I needed these to go to a couple different places. I'm making 85, 50 go to modular engines, 15 go to cooling devices, and 20 go to the turbo pressure motor recipe. And the way that I load balance these, none of these are a convenient number to work with, so even pairing up 2 of them or 3 of them really isn't going to work. So I needed to group all of them together, so I have my full 85 headed into a smart splitter. And I just used that split belt trick where there are 2 different speeds to make sure that this stays completely full, since this won't be a completely full Mark II belt since it's only 85 out of the 120. But that'll make up for the gaps, and then I'll get a full 60 out of here. I'm going to split it 3 ways, so 20, 20, and 20. So this 20 right here is just going to go straight on up to the turbo motors. With this 20 right here, I'm going to send that over here. And what I want to do is split off 5. So we've got 20 into the splitter. Here's 10, here's 10. Into the splitter, there's 5, here's 5. So we send 5 to group up with everything else, leaving me with 15 in this merger, and these can head off to the cooling devices. And I group up the rest of it, and I've got 50 for the modular engines. And here's the bus that's coming from the red jungle, and it's bringing in the 2 lines of coal and the line of aluminum. And that just leaves my favorite part. Now we get to turn this all on. Alright, we've got Inspector Bean looking at the drone port. I don't know why he's on top of it, but, you know, satisfactory things. So normally this is where I would flip the switch and we watch it all come to life, but it's obviously already turned on. So what I need to do instead is connect this last connection. This won't actually start the factory. It does connect all the power to all the machines, but to get everything really started, we need to come downstairs. Alright, here we are at our sinks. So once we flip this switch, turn it off, it'll send everything to the factory. And here we go. go. First two thermal propulsion rockets. So they're all staying on, and I have a steady 10 per minute thermal propulsion rockets headed to the drone port. So that means I have one last step, and that is to go over to the other drone port, turn it on, I'll get them sent into the space elevator. Alright, and here we are at the space elevator. So it is that time. Second to last part. And here we go. And there we go. The nice, steady, even load balanced 10 per minute thermal propulsion rockets headed to the space elevator. And with the magnetic field generators backed up, if we head over here, we can see they are joining up with the assembly director systems. And we've got a nice parade of space elevator parts being turned into coupons. And that is mission complete. So all in all, it really wasn't too bad. It did take me a bit longer than I was anticipating. Thought I could get this done in a week after the last video, but I was horribly mistaken. But thankfully, even though these are one of the more complicated space elevator parts to put together, it really wasn't too bad with planning ahead, and I already had all the fused modular frames and pressure conversion cubes that I needed ready to go ahead of time. And the rubber and the aluminum ingots. So being able to plan out some of these last factories ahead of time can really save you a lot of headache when looking at the picture as a whole. It did take quite some time, but the power finally did fix itself. So now, finally mission complete. So there's one last space elevator part to go, so it'll be time for some nuclear pasta. Look forward to that. And thanks for watching.